G'day guys, we've got a molecular and empirical formula question today where we've been given percentage composition information about phenyl magnesium bromide, and using those percentage composition numbers we've got to try and work out first of all the empirical formula of phenyl magnesium bromide and then its molecular formula using the fact that it has 181.313 grams per mole as its molar mass. So what we're going to do to start with is the insight that I'm hopefully going to give you with these sort of questions is because we're doing empirical formulas, and empirical formulas is just the ratios of each of the constituent atoms within a molecule, the mass that we actually use to start with is completely arbitrary. So in a question like this, what I'm going to do is I'm going to say in 100 grams of this phenyl magnesium bromide, we're going to have 39 and a bit grams of carbon, 2.7 grams of hydrogen, 13.4 grams of magnesium, and around about 44.1 grams of bromide. So what we're going to do is we're going to put all those into a table so we can see it a little bit more clearly. Great, so we can see in 100 grams, these are the masses of each of the constituent atoms within this molecule. So what we're going to do next is we're going to work out the number of moles of each of them. And what I've done is I've just put down a molar mass table for us to reference while we do the molar calculations. So let's start. So we have the number of moles of carbon is going to be equal to the mass over the molar mass. So we're going to have 39.7458 over the molar mass, which is 12.01. We're going to have the number of moles of hydrogen is equal to the mass, which is 2.77956 over its molar mass, 1.008. We're going to have the mass of magnesium. So the number of moles of magnesium is equal to the mass of this, which is 13.405, divided by the molar mass of magnesium, which is 24.305. And we have the number of moles of bromine, which is equal to the mass, again, sorry if I'm being repetitive. The mass of bromine is the mass that we've been given, 44.0697, divided by the molar mass, which is 79.904. Cool. And so for each of these, we get a number of moles of carbon, which is equal to 3.31. We get a number of moles of hydrogen, which is equal to 2.7575. We get a number of moles of magnesium, which is equal to 0.5515. And we have a number of moles of bromine, which is equal to the same as the magnesium, so 0.5515. Now, hopefully you guys are sort of aware of how empirical formula questions work. What we have to do is now we have to find the ratio of these molecules to each other. So the way that we do that is we find the smallest molar quantity, which in this case is a perfect tie between magnesium and bromide. So what we're going to do is we're going to then divide every number by the smallest value. So here it's going to be divided by 0.5515, divided by 0.5515, divided by 0.5515, and this one is divided by 0.5515. Cool, and it's pretty obvious that these two are going to be equal to 1. Now this one here, if we do the math, it's going to be equal to 5. And if we do this one, it's going to be equal to 6. Now we've been quite lucky in this question, guys, where we haven't been given none of these numbers have come out like 5.5 or 1.2. They're all basically spot on the whole numbers, which is quite refreshing, to be honest. So what we can do from here, then we just go the empirical formula is equal to C6 H5 Mg1, we don't have to write 1, Br. And this, my friends, is our empirical formula. Okay, so we've done the empirical formula part of the question. Now we just have to do the molecular formula. Now, the molecular formula is done by working out what the molar mass of the empirical formula is. So we're going to work that out first. So capital M, the empirical formula. And that's going to equal 6 times 12.01 plus 5 times 1.008 plus 24.305 plus 79.904. Cool. Put them into our calculator and we get 181.309. Now, it says in our question that the molar mass of this compound is 181.313. Now, what we can say, if we're in an exam and doing this question, we would basically assume that this is roughly equal to 181.313 within the margins of error of our experiment. So then we can say, therefore, the molecular formula for this compound is equal to the empirical formula, which is equal to C6H5MgBr. Okay, so let's just go through what we did here, guys. First of all, now that's the molecular formula done. Great. So, first of all, what we did is we were given the percentage by mass composition of this phenyl magnesium bromide. Now hopefully what you're going to take away from this is in empirical formula questions, we're just dealing with the ratios. Like we have 6 carbons to 5 hydrogens to 1 magnesium to 1 bromide. So because we're only dealing with ratios, the initial starting masses that we have are completely arbitrary. It doesn't really matter. So what we can do is if we're given a percentage composition question, we can just say, well, if we're given 100 grams of the product, we're going to get this much of carbon, this much of hydrogen, this much of magnesium, and this much of bromine, because their actual masses will not change. What we then do is we find the number of moles of each of them. Once we've found the number of moles, we then use the smallest value for our molar amount, and that is going to be our reference point. And then we divide all of the molar quantities by our reference number. Now, in this case, I forgot to put moles. So once we've done that, we're going to come out with numbers. You'll always get a number 1 when you divide the reference number by itself. In this case, we had 2 exactly the same molar amounts, and they were both the reference number, so we're able to get 2 1s. And then what happens is you'll hopefully pop out with a 5, or you'll pop out with a whole number and another whole number. Once you've got the numbers, you then just write down your empirical formula with each of these numbers corresponding to the number of that particular atom in the molecule. Now, to work out the molecular formula, what you first have to do is you have to work out what the molar mass of the empirical formula is. So we had to work out what the molar mass of this was. Once we work that out, what we're looking for is we're looking to see what kind of multiple the actual molar mass is of the empirical formula. For example, if this was, say, 362 grams as the molar mass, rather than that, what we could say from there is we could go, well, the molecular formula is equal to 2 times the empirical formula. So the molecular formula would be equal to C12H10Mg2Br2. So you can see that, having this accurate is very, very important. But what you do is the number that they give you, you see how many multiples it is bigger than your molar mass of your empirical formula, and then you just multiply your empirical formula by that amount. But yeah, that's about it, guys. It's not too hard a question. It might take a bit of practice to get used to, but going through it a couple of times will definitely help. So, what I suggest, guys, is just find yourself 2 or 3 of these problems, go through them one after the other, and you should be pretty sweet on this topic. So, if the video helped, guys, definitely give me a thumbs up. If there's any questions that you have on this particular problem or any other problems to do with chemistry, leave them in the comments section below. But, until next time, guys, if you want to subscribe to my channel, throw me a like. It helps my channel out. And make sure, last of all, that you enjoy your chemistry.